Yeah, Fatehpuri Sahib students, good evening everyone. How are you? Everything is good? Great. So this is the first numerical on your screen. Students, please solve this numerical fast, okay? Because it's an important numericals. Whatever the things which we have studied in the previous classes. Yeah, very good, very good. Fatehgarh Sahib students, very good. Very good emojis. Let me send one to you. This is JNV Fatehgarh Sahib students. I don't know which one. Two Fatehgarh Sahib students are there. Which to send? Anyone? Okay, I'll send this. Let us check. I'm sending emoji. Okay, I have sent. Now don't play with these emojis, okay? Like focus here in the class. This question is much important than that. So this is the first question. Figure shows the wavefronts in still water. You know, whenever we take some water, if you dip a stone or ping pong ball in the water, the different kind of ripples are being generated. So it's same here. Let's suppose the wavefronts in still water moving in the direction of the arrow towards the interference PQ. Suppose this is an interference. This is what? Interference PQ. This interface PQ. Between a shallow region and a deep, denser region. This is a shallow region here. This is a deep region here. So which of the lines may represent one of the wavefronts in deep region? Suppose this is the first, second, third, fourth. Suppose when the wavefronts go from this shallow to the deeper region, which of these 4, 3, 2, 1 will represent the lines or the wavefronts? So it is basically asking among this 1, 2, 3, 4, which one is the wavefront in the deeper region? Wavefront in the deeper region. And which one is the wavefront in the deeper region? 1, 2, 3, 4. Your option is A, B, C, D. Answer it. I'll give you 2 minutes to solve this. Your time starts now.
Don't worry, I'll give you the precise solution. But before that, you have to solve it yourself, okay?
Okay, now let us see. So I'm providing you a solution here. Watch it carefully. Okay, I'll explain full. Don't worry. So solution is this. Suppose you're having interference like this. Okay. And wavefronts, planar wavefronts are generated like this. These are the planar wavefronts moving. Okay. See what happens. We know this thing that if suppose there are circular kind of wavefronts generated, if we want to find the wave directions, how we'll find the wave directions? It is like this. And if this is like a spherical wavefront, still, if we want to find the wave direction, it is perpendicular to this, like along the radius, concentric radius of these circles or spheres. Okay. Similarly, students, when there is a planar wavefront generated, the wave direction is perpendicular to this plane wavefronts. Okay. This may be, it will be perpendicular to the wave direction. Now, it's sure if the wave is passing from a, say, like it was shallow and deep, now it's like a rarer and denser medium. If we just talk about the wave direction, that is this wave direction, it will bend. It will bend, no, because it is passing from a rarer to a denser medium. So it will bend towards the normal. This is the angle of reflection. Okay. So I will say wavefronts will follow this path. Okay. So according to this, if you see the option, the fourth is the most precise option. Wavefronts will follow this path. This fourth is the most precise option because it follows the laws of reflection, passing from a rarer medium to a denser medium. Is this thing clear, students? Reply in the chat box. Is this thing clear or not? Students, is this thing clear or not? Answer is fourth. That is our option number D is the correct answer. Let me highlight it. Okay. Okay, that's fine. Genuine Shimla says yes. I hope for all other students the answer is same. Cool. Now we'll see. Yeah. One more student have replied. Very good. Whatever. So see this. Question number second in front of you. Students, this is a 5-star question for you. I'll rate it as a 5-star question for you. Not that chocolate 5-star, but simple 5-star rated. Because this will revise your concept also and you can solve it also. This is 5-star question for you, numerical. Two coherent. Coherent matlab frequency same remains same everywhere 24/7 plus angle of what between two waves, that if the two sources are coherent, the initial phase angle will be constant throughout. It will not be the function of time. Okay, remember this thing. ठीक है ना? Now monochromatic matlab single, chromatic matlab wavelength. So when this coherent monochromatic light beam intensities are what? Intensities given are I and 4I are superposed. Okay. They're asking you the maximum and minimum possible intensities in the resulting beam. वो कितना होगा? Your options are this: A, B, C, or D. You have to answer it, students. Two coherent monochromatic light beams are I and 4I superposed. The maximum minimal possible intensities in the resulting beam are what? 5I, 5I, 3I, 9I, and 9I, 3I. What is the option? Answer it, students. What is the option? I'm giving you 2 minutes to solve this. Okay, answer it, then I'll give you the solution. Okay, let us see this. So, solution now will make. Okay, light beams are having the intensities I and 4I. Answer, let me give you the solution now. Okay, answer it. See, students, we have studied this thing. Then interference also, we have studied this thing that I max is given by under root I1 plus under root I2 ka whole square. And I minimum is given by under root I1 minus under root I2 ka whole square. Okay. Now we'll apply all these things. It's given in the question under root I1 is 4I. And see under root I1 is, hold on. Under root I1 is not given. It's given here I1 is equals to 4I. And I2 is given here equals to I. Yes, for the your students have given the right answer. C is the right answer. Good. Very good. Excellent. Okay. So if you find here I max, okay, this will give you the value equals to 4i का रूट I square. 4i का root is equals to how much? It is equals to, yes. Yeah, I know C is the correct answer. 2i root plus under root I ka square. This if you will solve, will give you the answer 3 under root I ka whole square. This will give you the answer I max is equals to 9i here. Okay. And I minimum value which you will get is equals to what? 4i minus I. This will be 2i, students. This will be under root I. Square if you'll do, this will give you I value. Okay. Yeah, C is the correct answer. So I max upon I minimum, if you'll see the ratio, students, let us see the ratio then. I max upon I minimum, the ratio comes out to be now 9/1. This is our answer. Remember it. Okay. So if you see the options, 9/1 is what? It is corresponding to these two intensities in the C option. So this is your answer. C is the answer. That is 9i and I. Because if you take the ratio of this, that is 9i upon I, the answer will come out to be 9, which is the required solution. Okay? 9 will be what? Your answer. Is it fine, students? You got the answer? Is it correct? Please reply in the chat box so I can proceed for the next question. If you got it, let us proceed towards the next question, students. Okay. Yeah. So, sure. Okay, good. So this is the next question here. So figure shown here shows a plane wave. This is a plane wave, students. Suppose it is like a plane wave. And the wave direction is, these are the plane wave fronts. Wave direction is like this, okay? So here they say you like this. If the wave is going from a air, which is what? A rarer medium, having some refractive index, say Na, subscript A. And if the wave enters from a rarer medium to what? A denser medium, which is water here, as shown. Refractive index NW subscript. So they're asking you from you that you have to find refractive index of water with respect to refractive index of air. Okay. And ratio also in the terms of these letters A, B, C, D, E. So you have free fill up this blank, fill this box. Either this will be A option A by E, B option B by E, C option B by D, D option D by B. So what is your answer? Remember, I mean, try to solve it. I'm giving you 2 minutes seed hint. I'm giving you how to solve. Hint is this geometry you have to use. Geometry you have to use sine angle, sine I, sine R. You have to assume, and then use the Snell's law. And when sine I, this much hint is more than enough. You can solve the complete question by using this. Geometrical hint, geometry you have to use. Find the sine I, R angles, use angle of incidence and R as per your choice, and then find the answer in the terms of letters A, B, C, D, and the options A, B, C, D, capital. Okay. Your time starts now. So students, your time starts now. Okay. Okay. So Shimla students say it is C answer. We'll check. We'll check. Hold on. Have patience. We'll check. Okay. What about other students? All of you must solve it. Okay, so what is the answer? A, okay. Jinvi Roper says D is the answer. D answer मतलब small d by b. Yes, very good students. Excellent answer. Okay, very good. So now I'll give you the solution. Please be very much careful while watching the solution because it's very important. Okay. Yeah, D. That only I'm saying. See, the question is like this. Suppose you're having a boundary. You're having a boundary like this, which is separating two mediums. This is a student's denser or rarer? It's a rarer medium. This is a denser medium. Okay. If light ray enters from this rarer medium to a denser medium, light ray enters from like this rarer medium or denser medium like this. Okay. And if we see ABCD distances, A, B, C, D. So it is A, it is B, it is C, it is something D here. Okay. And E is given by this. So simple as students, if I assume the angle I here, R here, similarly here also I R. Why? Because these both the rays are parallel. I'll get sine I is equals to B by what? I'll get the answer B by D. Okay. If I find sine R, I'll get geometrically. See, this you have to do yourself. I'll get it as what? I'll get it as C by, sorry, hold on. So sine I is equals to what? Sine I is equals to B by D. And if I check for other, I'll get what? I'll get sine. Okay, fine. So there is some mistake here. This is sine I and that is sine R. Let me draw it somewhat proper. This is ray, B coming, this is T. This is normal, normal. Ray coming, ray going, ray coming, ray going. This, if you see in the option, this here is A, this here is B, this here is C, this here is G. And if you connect the E option there, this here is, if you see here, this will come out to be E option. If you mark here I angle, this is R angle. If you mark here I angle, this is R angle. You will get what? You get sine. Okay. I angle to be what? You get sine I angle to be what? B by C. Sine R angle you will get as what? D by, focus here carefully. Sine, are you getting? No, it's B by C. Okay. Sine R is D by C. So we knew the Snell's law now. Snell's law says what? It says N of air sine, because angle of incidence is in air. Angle of reflection is in water. The sine of air and B sine of water will give you the value. Okay, like this, it's for the water subscript. So sine A is I, sine W is what? R. So we'll get the answer B by C. That is N of A, and W will get as D by C. CC will cancel. So the answer comes out from this equals to Na upon Nw is equals to D by B. Na upon Nw will give us D by B. Yeah, that's right. You're right. So answer will be, students, D by B. Okay, because we're getting Nw upon Na is equals to how much? Hold on. It's B by C and it's D. So Nw upon Na is B by D. Yeah. Answer will be C, students, not D. You're wrong. Answer will be C. Because Na के साथ with Na air there is what B, and with Nw it is what D. So we'll get what we want, what Nw upon Na. So Nw upon Na will give you B by D as an option. Okay, so C is the answer. I hope it's clear. Is it right, students? Yeah. So now this question in front of you. It's just a theoretical based question. If you have read the theory, you will be able to answer it. So the question is asking from you, when the light is refracted into a denser medium. So if the light is passing from a the light is passing from a rarer medium to a denser medium, you have to answer its wavelength and frequency both increases, or the B option, its wavelength increases but frequency remains unchanged. Wavelength decreases, frequency unchanged. Wavelength and frequency both decreases. Among A, B, C, D, what is the option? Please write in the chat box. I'm waiting for your answers. Genevieve Mandi student says C option. Wavelength decreases. I think this question you have seen in terms test maybe. Wavelength decreases but frequency remains unchanged. Let us see. C. Shimla says C. Good. Okay, इसमें कुछ wait करने का नहीं है. Let us directly solve it properly. Okay. Now I'll give you the solution. See here. So solution in front of you. See, we know frequency of a light wave is given by this formula, C by lambda, where lambda is what? It's nothing but wave length. C is the speed of light, which is given by the value 3 into 10 to the power 8 meter per second. Mu is the frequency. Okay. Remember, when a light ray is in air or vacuum, it is having C speed, suppose. But when it is in some medium which is having a refractive index as n, so speed of the light changes in the medium, m subscript means medium, changes into equals to how much? C by eta or n, which is a refractive index of, this one is a refractive index of medium. Okay, that's fine. If you put this formula here, suppose in the vacuum, if this is a frequency lambda of light, so what happens when the light ray passes through a refractive through a medium which is having some refractive index? It will be C by eta upon lambda. Okay. See, according to this, frequency must change and lambda is constant, but this doesn't happen actually. Remember, so what is happening? Speed will change, that's fine, but lambda will also change in such a manner that frequency remains constant. Okay, so we'll say like this. Students, ki, as you know, if I want 2, I can, how can I find the 2? I can divide either 4 by 2, numerator and denominator, or I can divide 8 by 4, numerator and denominator. So you can see numerators are changing and denominators are also changing, but the net quantity remains constant. Similarly, frequency will be constant in this case. Even the speed changes due to refractive index. I mean, the light ray passing from one medium to another, rarer or denser, and lambda will also change. Okay, but lambda will change in such a manner that it remains constant. So for it will be decreasing. Okay, for net to increase. So we'll say that answer will be C option, that wavelength will decrease. Let me highlight this. Wavelength will decrease. Okay, but frequency remains. Wavelength will decrease, but frequency remains unchanged there. Wavelength will decrease, but frequency remains unchanged. Is it fine, students? Wavelength decreases, but frequency remains unchanged. Okay. Please reply in the chat box if this option is cleared. Please reply in the chat box if it's cleared. Okay, very good, very good, very good. So you replied, it's good. Okay, Shimla says okay. Students, now this question in front of you is advanced level numerical. Okay, so we'll solve it. Although it's easy for those who know the theory, but for those who know the theory and haven't practiced, I mean, for practice, the people who are practicing, for them, everything is easy. But for those who don't do practice, it's bad. I mean, you're not able to solve this. So this is a good level, advanced level numerical. Advanced level numericals. Let's give it 10 stars. 5 plus 5 I'm writing here. Okay. So the question is in front of you. I'll read it and you have to solve it first. I'll give you 5 minutes because it's an advanced numerical. It's what? An advanced. A beam of light consisting of two wavelengths, 6300 nanometer is angstrom. Sorry, it's the first one. So this is first one, 6300. I have highlighted it properly. And lambda Armstrong is used to obtain interference fringes in Young's double slit experiment. The fourth bright fringe, of 6300 Armstrong coincides with fifth dark fringe of lambda A Armstrong. A fourth bright fringe of 6300 Armstrong. This is fourth bright fringe of 6300 Armstrong coincides with fifth dark fringe of lambda Armstrong. Then the value of lambda is equals to how much? Okay, A, B, C, O, D. They're asking the answer. The time starts now. It's simple. Use the formula for the bright fringe and use the formula for the dark fringe. We know formulas are same. Lambda beta is equals to what? Lambda capital D by D. Compare them both. We are putting the proper integer values. Okay, and you will get the answer. This is the hint. Solve it fast. You're having 5 minutes. 5 people, 5 minutes. Okay. Solved? No one? Okay, let me give you the solution of this also. So maybe this is the last numerical. Okay, one more numerical we'll solve and then we'll end the class. So I'll slow it in a very slow pace. Okay, don't worry. See, what was the question? Let us see it carefully. The beam of light consisting of two wavelengths, 6300 Armstrong and lambda Armstrong, is used to obtain interference fringes in Young's double slit experiment. Okay. If fourth bright fringe of 6300 Armstrong, I mean the fourth bright fringe of 6300 Armstrong. Okay. So let us write everything. Fourth bright fringe. This is bright fringe. Fourth bright fringe having the lambda equals to 6300 angstrom. Angstrom matlab kitna? It is equals to 10 minus 10 meter. Okay. And next, if you see, coincides with the fifth dark fringe of lambda Armstrong. So fifth dark fringe. Fifth dark fringe का मतलब क्या हुआ? They're just telling the lambda value. Okay. So they're asking from you. You have to find the lambda now. They haven't given the lambda. They're just told like this. This both will coincide. Coincide matlab overlap. So it's like this. Suppose one circle is there, and other circle of the red color periphery and having the same radius overlap this white circle. So can you see the white now? No. Although there is some error in the drawing, but if you take it practical condition, there will be no error. I mean, there will be, you'll not able to see the white circle there. That's fine. So this is known as overlapping or coinciding. So there is some interference pattern, and due to that interference pattern, the fourth bright fringe of a particular lambda this and lambda, some other lambda of light, whose fifth dark fringe will coincide with this. So you have to compare the formulas and find the lambda value. Okay, it's very simple. Okay. Is anything else given in this question? Nothing is given. Nothing is given. Simple as students, you have to use a formula. What kind of formula you will use? कैसे करेंगे? Anyone, students? Anyone of you? See, it will be like this. Let me tell you. So I will say, for the bright fringes, we know for the bright fringes, part difference we found it was n lambda, n times lambda, and for dark fringes, our part difference was somewhere it is 2n minus 1 lambda by 2. Okay, no, we can take it here directly as this. See this. Lambda by 2, we'll take it as lambda by 2. Okay, simple. And lambda by 2. And what? Lambda by 2. But this depends. इसमें if n is 0, you'll put n0 directly. If n is 1, you'll put n1 directly. N is 2, you'll put n directly. N is 3, you'll put n directly. N is 4, you'll put n directly. N is 5, you'll put n directly. इसमें if it is first dark fringe, you will not put 0 here. Okay, yes, if you put 0 here, this will be counted as first. If you put 1 here, this will be counted as second. If you put 2 here, this will be counted as third. If this is 3 here, it will be counted as fourth. So if I say it is fourth, and if n is equals to fourth, and if you want to find the fourth fringe, it will be counted as third. Okay, and if you see, these are the numbers of the fringes: first dark fringe, second dark fringe, third dark fringe, fourth dark fringe, and these are corresponding integers values. Okay, n2, n3, and 4. If suppose n is equals to 5, then I will say actually I'm finding what? n5 means you will get the fourth dark fringe, and then like this it will be. Okay, so here the value is given as fifth dark fringe, hai na? Simple. So what do you need to do? What do you need to do, students? Anyone? I've given a lot of hint, so please reply it. अरे देखो, let me write it again. Bright fringe के लिए if you see, the part difference is n lambda. ठीक? And if I see that, oh, hold on. For the dark fringe, hold on, students. This is for the bright fringe, okay? And the bright fringe value is given as what? It is given as fourth bright fringe of 6300 Angstrom. So in the maxima formula, you can use directly fourth bright fringe. Okay, so 4 into lambda will put part difference like this. That is coinciding with this is coinciding with what? With the dark fringe. Dark fringe के लिए formula था 2n plus 1 lambda by 2, simple formula. Take it as let us take the general formula. Leave the basic formulas in between. Let us take the general formula. This is the part difference. Okay, 2n1 plus lambda by 2. Yeah, this is fine. So n is given as what? N is given here as directly 5. Put the value 5. So we'll get 5, 10 plus 1. Hold on. 2, 5, 2, 5, 10. Yeah, 10 into lambda by 2. Lambda is how much? Which fringe is given? It's the fifth fringe, okay? So you will use not this formula, actually use the -1 formula. So you'll get here what? 2 for the 10 minus 1 lambda by 2. So this will give you 9 lambda by 2 students, okay? This is 9 lambda by 2. So lambda here will be used for the bright fringe. Why I use this formula? Because they are telling here, I explained, you know. See, if you take the n5, this will give you the fourth fringe, okay? And I want the fifth fringe. So if I'm using 2n plus 1 formula, I want the fifth dark fringe, no. So I must place here n6. But I need a formula where if I want the fifth, I must place the fifth only for the dark also. So I will use 2n minus 1, okay? So here you will use 2n minus 1, that is this. And this lambda will be of the dark. Put the values. Okay, so let us see the combination there. Combination is this 4 into lambda of the bright. Lambda bright is 6300. And next is what 2n minus 1. N is what? Directly you can put fifth, matlab fifth dark fringe, you will get it. But in this formula, if you want the fifth dark fringe, you have to put n equals to 6. Otherwise, you will not get it. So we'll use 2n minus 1. And 5 matlab 10 minus 1, 9. Lambda by 2. Lambda I need to find. So your answer will come out to be what? If you solve it, this will give you the answer equals 2. Let us see. 2 4s are 8. Then again 6300 upon 9. 9 7s are this. 6. So we get this answer as 5600. So D is our option. So D is the answer, students. Okay. What is our option? D is the option. So D is the answer. Is it clear? So we have just used the basic formulas, basic fundas we have used. That is, let me write the summary here. We started with the bright fringe. So remember, for the bright fringes, actually the fringe width is given by beta, lambda capital D by D. It is used here. We use those. We know the part difference is given for the bright as n lambda. N is, if it says central, you'll use n0. If it says for the first bright spot, n1, for the second bright spot, n2. But if we talk about the dark, okay, dark spots, there the part difference, beta is same, but there the part difference, you take it as 2. If you take 2n plus 1 lambda by 2, no, the problem is there that if you need to find for first dark fringe, suppose you need to find a first dark fringe, you can't use here n equals to 1. You will use n0. So that is some little bit error of this. I mean, it's not wrong, by the way, it's right, but it's not for your convenience. I mean, you may get confused. So the formula which we have made is this, that is 2n minus 1 lambda by 2. In that, if you put n equals to 1, this will give you automatically first dark fringe. If you put n equals to 2, this will give you automatically second dark fringe. So similarly, you will progress. Okay. So these are two formulas. With this, we have found the answer. That is this. Is this fine, students? So are you feeling any doubt? If you are having any doubt, please reply in the chat box. Janvi Shimla students, if you're facing any doubt, please reply in the chat box. Now we'll see. Not this. Not this. Okay. So that question is completed. If you're facing any doubt, please ask in the chat box. Okay. No doubts. Okay. So I'm giving you one question as a homework. I've given in the previous class also. This is okay. This question let us do more. Okay. So see, this question take as a homework. Okay. So I'll give you a hint. So what is happening that actually some rays, see this, microwaves. Suppose this is a transmitter. This is T for transmitter. Microwaves are coming from this, okay, kind of transmitters. And there's a reflector here. It will reflect it. And there is some detector which is moving normal to the reflector. What happens? It passes in between many of the spots, bright spots, and the number of bright spots which it passes in between is given as 14 in number. But in between there are dark spots. So distance it has traveled in between these bright spots is basically equals to given as 0.13 meter. Okay. So what you have to do, it's very easy here. You have to find the velocity of you have to find the frequency of the transmitter. But for that, you must have first find this lambda. Okay, then only you can find it. So this is your question. This is the question as a homework for you. Try to solve it, and then we'll see in the next class. Okay, what happens? So you understood the question. If you don't, just read it twice, you'll get it. Okay, it will be in the PDF. So are you having any doubt? You can ask in the chat box now. If you're facing any doubt, you can ask in the chat box. If not, then we can end the class. Is it fine? Any doubt you can ask. Any doubt. Suppose not from wave optics, any other question, if you have solved it and if you're facing any doubt, you can ask now. Any one of you. Any one of you, if you're facing any doubt, please ask. Because numericals are this much is enough for your class. Okay. Next week we'll see what to do. I mean, we'll continue wave optics only, but if there are some changes, it will be notified to you. Please reply in the chat box if you're facing any doubt. Okay, material, about the material you want, I'll provide you in the link, but if still you're facing doubts, you can reply me on this number. Okay, I mean, you can either call for help. Okay, I mean, you want some counseling kind of thing, or sir, kaise, how to study this subject, like physics mein, how was the way I'm reading again and again. Some students are having the complaint that sir, we are studying daily, but if I take one question for a week pass, suppose I took a question from the rotational mechanics a week before, and then again, if I completed it, and the next week I'm taking SHM, and then if someone is asking from me the same question from HCB, I'm not able to solve it. So this means that logically you didn't understand that question conceptually also. Okay. So for that, if you need a help, I tell you, you have to go through a particular process. Okay, first go basic by basic, understand what is happening, feel the topic, see the YouTube animation videos also if you can. Okay. If still you're not able to understand, you can ask directly, call me or like WhatsApp me. If you want the modules, there are many soft copies like PDFs available. Okay. PDFs available. So there are many PDFs available here. So let me add PDFs. So if you want any modules of any subject, physics, especially physics, yeah, physics में किसी भी institute का, if you want LN also, I will provide it. Okay, but PDF copies. Okay, no. Okay, bye bye everyone, students. This is the time to end. Now I'm launching NPS. Please participate in this NPS, then you can leave. Okay, very good. Yes, bye bye all the YouTube students. If you're having any doubt, can reply. I'm here on the YouTube chat box also. Reply in the NPS, please. Okay, bye Shimla students. There's no water here. Okay, bye bye everyone. I've ended the poll. Okay, so we'll meet in the next class. Bye all the YouTube students.